We now have the 666 pancake coil system rewired and placed up in space with glass bottles underneath so we can gain access to bottom fields for testing if need be. Right now we have two secondary inductors, one over phase 2 and one over phase 3. We've been running this alternator now for almost an hour in an unenergized field state. This to show one of the problems that may develop in testing in that unenergized field state. We don't have a label on phase 1. Grab a marker here. Phase 1 is 0.14 amp, phase 2 0.12 amp, and phase 3 is registering 0 amps. Often in the unenergized field state, after a prolonged running time period, we'll lose one of the phases. So it's actually acting like a two-phase system more or less. Now here is the field conditions that we normally get from that secondary system that we use for the 9th embodiment of the wireless Tesla coil. We use two secondaries in series. As you can see on the right secondary, we're getting 102 volts. That is the back secondary. Coil completely in the back, which is our coding system shows, is phase 2. The coil in front of that is phase 3. It has a secondary over it. That secondary is picking up 102 volts, and the first secondary is picking up 171 volts, and we can obtain 275 volts between them. Doing a phase angle analysis from those three numbers, I see that's usually about 127 degrees, somewhere close to 130 degrees phase angle difference right there. We also have the amperage meter on each phase, and initially I ignored that important information because of assumptions. On other videos, I've stated that these secondary coils are 7,000 ohm reactances. They are balanced by approximately 50 nanofarad. The back coil that we're looking at there producing those things, as I've said, should be from a 7,000 ohm reactance. All we need to do is divide the voltage by the amperage and to see what the real reactance is being shown. And it's the same thing with over here. When we do that, we find a surprising thing that probably doesn't develop in line connected circuits, but these are air core connected circuits. We find that indeed the first coil, as predicted, came up to the near quoted 7,000 ohm reactance, but the second coil is only is functioning as if it were a 5,100 ohm reactance, and we know this cannot be for the simple fact that the LCR meter measurements of the coils are 2.6 henries, 2.6 henries, and 2.7 henries. So the 2.7 Henry in balance with the supplied 50 nanofarad is resonant. It has too much inductance, we suppose, and we also notice that it then doesn't get as much voltage across it, and it also has a reduced amperage. So we're comparing 20 milliamps from the coil in front with the coating scheme to the coil in back, which is that right there. Now, what we're going to do then is we're going to lift these coils up off of the source, and we're going to turn the field on. We have to do this because of the fact that our meters have a 750 volt upper limit, and the way things are designed here, I only have a lowest field value near 6 volts, which would skyrocket the secondaries voltage. So first we'll go in there and lift them coils up out of there, get our other information out, and then we'll look and see whether, in fact, when I do this, we'll be watching and looking on that phase 3. Exhibiting 0 amperage. Whether in fact that phase 3 will be restored once we energize the field. So we're going in there, we're going to back out a little bit there. Get in here and do this work. Come back and look at the camera. This was the coil. Not correct, huh? That's the coil where we lost our inner lead. Hopefully that'll restore something. We got amperage there. No, we don't have amperage there. Yes, we have amperage there. Okay, so that's scrub, that's my equipment. I'll deal with it. Okay, we have that one elevated. That should have went down to 0, and it did. Now we can elevate the other one. Notice that very good result there, I see. Set the blind man. Okay, I guess that wasn't of importance. We got 2 milliamps from there. We got 6 milliamps from there. Our voltages are now reduced to 35 and 64 volts. We're in the same problem with turn the field on at 5 volts. See if we get a restored phase 3. We're wondering whether we can get phase 3 working, and what's the malfunction going on here. Let's also take a quick look at that again. We've got 60 volts in the front, 35, 62 volts in the back, 36 volts in the front, 77 volts between them. The phase angle changed. But we're not concerned with that for now. We would go for our phase 3 test. We'll call that quits probably. Okay, I see we got a loose wire here. Yeah, right, Jake. Where does that go? What is going on here? That's the return. That's the cap. Okay, see all this bullshit? We got it. Right there's our amperage. So this is what you gotta go through sometimes. It's fucking amazing. Okay. So as you can see, look at our meters now are pinging out. Exactly as I suspected. 758 volts on that thing. I don't think I should be running it very long. 48 milliamps on the front coil. Milliamps on the back coil. And I don't know what happened there. Something happened. Oh yeah. As I said, we're going to quit from here and note the voltage is on the system. We're exceeding the voltage recommendation for one of the meters. There's our 80 milliamps. Here's the conditions on the main circuit. And we'll call that quits for now then.